Okay, I will be going over problem 10 in the next problems. So let's start. Say that there are two donors considering whom to back in the upcoming presidential primary, either candidate AOC or candidate CP. Both donors want party unity in which both donors back the same candidate. However, donor 1 would rather the party unite around AOC rather than CP, while donor 2 would rather the party unite around CP. For both donors, a fractured party is the worst thing. Okay, so we have candidate 1 would rather prefers AOC, and then candidate 2 prefers CP. So A says, say that donor 1 chooses whom to back first, then donor 2. Model this as an extensive form game. For donor 1, use the payoffs. So for 1, use the payoffs 0, 1, and 2. 0, 1, and 2. And for donor 2, use the payoffs 0, 1, 2 as well. Okay. So let's start off with donor 1 beginning the game. Donor 1 could either go for AOC or CB. AOC or CB. Now 2 could either go for AOC as well, or for CB. And if player 1 goes for CB, 2 could also go for CB or for AOC. So up here in this node, if player 1 goes for AOC, which is what is preferred, and 2 goes for AOC, then they both go for AOC. So 1 gets 2. Player 1 gets a payoff of 2 since it's the choice, it's the candidate that they prefer. Or I'm sorry, the donor. The donors choose AOC, so the donor 1 gets a payoff of 2. And 2 chooses AOC, which isn't who they want to choose, but it says that the worst thing is if they are a fractured party, which they aren't. So instead of a 0, they get donor 2 gets a 1. Over here in this node, donor 1 chooses candidate AOC, which is what they prefer, and 2 chooses CB, which is what they prefer. However, it's a fractured party, so they both get 0 and 0. In this, down here, this payoff, 1 chooses CB, which is what they don't prefer, and 2 chooses AOC, which they don't prefer. They don't prefer either, so they both get 0, 0. Down here, donor 1 chooses candidate CB, which they don't prefer, and 2 chooses CB, which they do. However, they both are in the same, they both choose the same party, so it isn't fractured. So although 1 doesn't get the candidate that he wants, he still gets a 1 since it's not a fractured party, and 2 gets the best possible outcome for choosing for the candidate being chosen that it prefers. So now that we have this, we find the pure strategy, we find the Nash equilibrium that's subgame perfect. So we start at the end and do the backwards method. So we can start up here in this node. So donor 2 can either get a payoff of 1 or 0, so it chooses 1. Now down here, donor 2 could either get a payoff of 2 or 0, so they obviously choose 2. Now, donor 1, if donor 1 chooses this up here, chooses to go the AOC route, then they get a payoff of 2, and if they choose CP, they get a payoff of 1, so they'll obviously go for the higher payoff of 2. So this right here, this is the subgame perfect Nash equilibrium. Now, in your opinion, is it better to be the donor who goes first or the donor who goes second? I think it's better to be the donor who goes first because the second donor will be forced to back the first donor's choice of candidate since it gives the best possible outcome. It gives the payoffs for both of them. So I think choosing first is always the better option. Okay, B says, now say that there are 3 donors, and again, each donor chooses whether to back AOC or CB. Donor 1 would rather the party unite around AOC rather than CB and DCB. And donor would rather the party unite around CB, and for both donors, a fractured party is the worst thing. So it's the same exact things as part A. So donor 1 prefers AOC, donor 2 prefers CB. Now, the third donor it says the third donor is most concerned that CB gets at least some support. The worst thing for donor 3 is if CB gets no support at all. Otherwise, donor 3 would like to also have party unity. So 3 supports CB. Wants CB to get at least some support, so we'll make sure. Okay. And the payoffs again are 0, 1, and 2. So this game's going to be a little longer, but let's start. So 1 starts again, and 1 once again can either choose AOC or CB. Now 2 could either choose AOC or CB. Then 3 could either choose AOC or CB. Again, up here, 3 could either choose AOC or CB. Down here, donor 2 could either choose CB or AOC. And 3 could either choose CB or AOC. And again, CB or AOC. Okay, let's start with the payoffs now. So, let's start up here. If donor 1 chooses AOC, it's the best possible outcome. It chooses AOC, 2 chooses AOC, and 3 chooses AOC. So this is the best possible outcome for 1. So get a payoff of 2. 2 chooses AOC, and 3 choose AOC. This isn't the worst possible outcome since there is party unity, so we'll give them a 1 and 1, although they prefer CB. The node right below it, or the payoff right below it, 1 chooses AOC, 2 chooses AOC, 3 chooses B. So once again, this is the best outcome for donor 1. However, 2 and 3, this is the worst that could happen. So they get payoffs of 0. Now, if donor 1 chooses AOC, 2 chooses CB, and 3 chooses AOC, donor 1 gets a payoff of 1. Since not everyone chose it, then donor 2 also gets a payoff of 1, since there is some unity and the parties aren't divided. However, 3 gets a payoff of 0, since there's no support behind CB and since it chose AOC. Now right below it, donor 1 chooses AOC again, 2 chooses CB, and this time 3 chooses CB. So this is the worst thing for 1, and this is the best thing for 2 and 3. Now, the one underneath for 1 If donor 1 chooses CB, and then donor 2 chooses AOC, and 3 chooses AOC, then this is just everyone gets a 0 since it doesn't go in anyone's favor. If donor 1 chooses CB, donor 2 chooses AOC, and 3 chooses CB, donor 1 gets 1, and then they get 0 and 1. This one right here, donor 1 chooses CB, 2 CB, and 3 AOC. This is the worst outcome for 0. However, for 2 and 3, for 2 this is the best thing, and 3 gets a 1. Last one, it'd be 1. All CB, there is some unity, which is why 1 gets a payoff of 1. And 2 and 3, this is the best outcome for them, since they choose CB. They prefer CB. So now that we have all the outcomes, let's try and find the subgame perfect Nash equilibrium. So let's start on top again. 3 could either choose 1 or 0. It choose 3. It choose 1. 3 could either choose 2 or 0. It choose 2. 3 could either choose 1 or 0. It's going to choose 1. 3 could either choose 2 or 1. It's going to choose 2. Now 2 could either choose 2 or 1. It's going to choose 2. 2 could either choose 0 or 2. It's going to choose 2. Now 1 is either going to choose 0 or 1, but it's going to choose 1. So the subgame perfect Nash equilibrium is this game right here. It's going to be donor 1 choosing CB, donor 2 choosing CB, and donor 3 choosing CB. And that's it for this question. Thank you.